Welcome to this video on query federation. I'm Cynthia Saracco from IBM. Query federation refers to technology that provides programmers with virtualized access to data from various sources. You'll find different federation technologies available in the market today, and as you might imagine, capabilities vary from one implementation to the next. I've outlined some characteristics worth investigating for any implementation that you might have in mind. Transparency is a common requirement, and that simply means that programmers should enjoy a single-site image of their data. In other words, programmers shouldn't need to know how or where the underlying data is stored. They should be able to work with it as though it were all in a single source. Of course, the underlying data is often heterogeneous and distributed across different systems. Despite this, a federated engine can provide programmers with rich query support and may even have enough intelligence to leverage unique capabilities of each underlying data source. SQL Query Federation debuted commercially more than 20 years ago, but interest in this technology area has grown thanks to big data. Some firms are using the technology to explore how data captured in their Hadoop-based data lakes might be relevant to corporate data stored in relational systems. Let's talk about when it might be a good idea to implement a federated data environment and when it might not be such a great idea. Federation is best considered when physically consolidating data from multiple sources into a single system simply isn't practical. Migrating the data might be too disruptive to existing applications, and copying the data might require developing and maintaining costly extract, transform, and load processes. Or perhaps your data analytic needs are hard to anticipate or require access to the most current data of record. However, federation isn't ideal for all situations. It doesn't address data quality or data cleansing issues. It simply makes it easy for developers to get to existing data on remote systems. And opening up existing data sources to more developers creates a greater load on those systems. After all, every federated request involving a remote data source will require that source to respond and return any qualifying data. Let's take a look at what's involved to set up and use a federated query engine. This example is based on IBM technology in Big SQL, IBM SQL engine for Hadoop. Basically, an administrator creates a few objects, which I've shown here in black. Let's step through them one by one. The first command identifies a wrapper or client library for the type of data source to be accessed. Here we're creating an Oracle wrapper. The next line creates a server object for a specific Oracle server instance on a specific node in the network. Next, we map a local Big SQL user ID to an ID on the remote Oracle instance. And finally, we define a nickname for a specific Oracle table. The final line, which I've shown here in blue, illustrates how a programmer using the federated query server would query that Oracle table. Note that there's nothing in this query that indicates the data's source or location. And that's the point. Programmers don't need to be aware of the differences between the various data sources that they might need to access. Everything appears like a single local SQL database. Of course, you can query more than one table at a time using federation. Here's an example of a select statement that joins two tables that reside in different remote systems. The application writes a typical query. The federated engine examines the query to determine an efficient data access strategy. In this case, the federation server generated a data access plan that instructed each remote data source to filter as much data as possible locally before sending results back for final processing. I want to spend just a minute talking briefly about performance. If you're working in a federated environment, be sure to follow the best practices for general query development. In particular, be sure that you write queries that specify only the data that you need. Because federation works over distributed data, it's important to include appropriate query predicates or filtering operations to minimize remote data transfers. In addition, assure that you have sufficient resources available to handle your workload. And get familiar with the performance tuning recommendations of your particular implementation. If you're curious about federation, you'll find a lot of information available online, and I've highlighted a couple of presentations from some recent conferences that might interest you. I hope you found this video to be useful, and thanks for watching.